Hello everyone. In this part of the series, we will go over some key statistical concepts that are vital to any well-done analysis. Keeping in mind that no matter the sophistication of the software tools you are using, if you are not good with statistics, then you will not be able to go so far, right? And that's because statistics are important to understand and decipher the different outcomes you get from the different analyses. In addition to the fact that you need statistics in order to control the different parameters of the experiments of or the analyses that you are going to conduct. So make sure to understand the crucial importance of developing a good foundation in statistics in order to be able to be a good data analyst or scientist. So, the first concept we will talk about is the variable. So, what is a variable in statistics? A variable is an attribute of an entity, and that entity can be a person, place, object, or even an idea. And the main property or characteristic of a variable is that the value of the variable can change or vary from one person or place to the other. So here let's take a few examples in order to illustrate the idea. For example, the height here in centimeter is a variable. So here we have a person with a height value of 150 centimeters. Another person has a height value of 180. Another has a height value of 135. So can you see how the value of the height variable varied or changed from one person to the other? Another example is the age variable expressed in years. So here we are talking or we are collecting data about the same person but at different points in time. So here we have the same person. At one point in time, the value of the variable age for that person was 1 year old. Then we took another measurement at another point in time, and this person was 25 years old. Another point in time, and this person was 80 years old. So as you can see, the value of the variable can also change with time. Uh, there are so many examples of variables that you can find everywhere. For example, the top speed of different cars, a variable called top speed that basically measures the top speed of different cars, right? Another example is the width variable, which is the width of different couches. A third variable could be the average weight of different types of fish, variable called average weight. A fourth variable called the population count, which measures the population count of different countries, for example. So as you can see, we have so many examples of variables. Okay, now variables can come in many forms, and the two main forms of variables are one, numeric, and the second is categorical. Numeric, as the name indicates, are simply numerical values or number values. And numerical values can be further subdivided into discrete and continuous variables. So what is the difference? The discrete variables are basically uh, integer variables or whole numbers, and these variables are counted most of the time. So some of the examples can include the number of patients in a hospital, or the number of cats owned by a person, or the number of heads in a multi coin flip. All right. The second type is continuous. These variables are normally uh, uh, measured rather than counted, and they can take any form or any value within a specified range. So, for example, the weight is measured, and a person's weight can be, for example, 120 pounds. If we used another scale, a more accurate scale, then the weight of the person can be 120.5. A more accurate scale can give a result of 120.564, for example. So as you can see, it can take any form and, sorry, it can take any value and the continuous variables are measured rather than counted. Some other examples can include the temperature, the height, the width, etc., etc. Now, the second type of variable is categorical variables. These are basically variables that come in the form of classes or categories. So they are not counted or measured in any way. The categorical variables can also can be further subdivided into nominal and ordinal variables. Nominal variables include classes or categories that do not have any specific order. For example, when we say male or female, right? We want to measure, we want to see the gender of a person, so it can be male or female. Another example can be a variable called the kind of pet. It can be a cat, a dog, a rabbit, anything else, right? So we don't have any order to these categories. On the other hand, we have ordinal categorical variables. These variables or the categories in these variables have a specific order, or the order of these categories has a meaning or meaningful. Some examples include the education degree, for example. We have bachelor's degree, master's degree, or PhD. PhD is clearly higher than master's, and master's is higher than the bachelor's degree, right? Another example can be the satisfaction level by a service. So the categories can be satisfied or neutral or unsatisfied. So again, the order of these categories is meaningful and is important to express the different categories. So make sure to understand the main two types of variables and the subdivided types of each. Okay, now let's talk about the measures of central tendency. And measure of central tendency is one subject under the main topic of descriptive statistics, because there are many types of of statistics. One of them is descriptive statistics, right? So now we'll talk about the measures of central tendency, which basically expresses the value around which other data points tend to concentrate. Okay, again, it's a measure of central tendency, measure the value around which the data points tend to focus or concentrate. And for that, we have three main measurements. We have the mean, we have the median, and we have the mode. So let's take a look at each one of them. First one is the mean. I believe everyone is familiar with the mean or the average in the language of mathematics. It's basically the sum of the data points divided by the number of the data points, right? So here we have on this number line some values as data points, and we want to count the mean for these values. So we have 7 plus 1 plus 5 plus 3. We have 10, 16 over 4, and the mean is 4. So here 4 is basically the central value or the typical value for these data points. Another measure of central tendency is the median, and the median can be especially helpful when there are outliers in our data points. Outliers are basically extreme values, right? Extreme values or observations that are not are out of the norm, simply speaking. Okay, so as we can see here, we have these data points 2, 29, 1, 6, and 4. Right, so 29 is clearly an outlier in this case. It's very far or out of the norm given the other data points, right? And in this case, the way to calculate the median is to first order the data points by saying it like this: 1, 2, 4, 6, and then 29, and then taking the value that is located at exactly the middle. Okay, in this case, it will be 4. So 4 divided all the data points into 2 halves. The point at exactly the middle is the median in this case. All right. Now, what if we had an even number of data points, like say 1, 2, 6, and 29? In this case, the median would be the sum of the points at the middle divided by 2. So 2 plus 6 is 8, by 2 is 4. 4 is the median in this case. Okay? So just make sure to understand when the median or the mode can be or the median or the mean can be helpful than the other, more helpful than the other. Okay, awesome. The third measure of central tendency is the mode, which is basically the data point with the highest frequency, or the data point that occurred the most in our data set, right? So, for example, here we have 3, 5, 3, 7, 6, 15, 7, 3. So let's write down each unique number and count the frequency of each. So we have 3, we have 5, we have 7, 6, and 15. These are the unique numbers. Now, the frequency here, for 3, we have 1, 2, and 3. So, the frequency of 3 is 3. For 5, it is 1, and that's it, 1. For 7, we have 7 here, and 7 here. So, we have 2. For 6, we have 1 here, and that's it, so it's 1. And then for 15, we have only 115. Okay, so now the value with the highest frequency clearly is 3. So 3 is the mode here. All right. And as you can see, the sum of this frequency is equal to the number of points or observations in our data points here, which is 8. All right. Let's take another example. We have 1, 2, 1, 5, 23, and 2. What is the mode in this case? So here we have 1, 2, 5, and 23. For 1, we have 1, 2, 2. For 2, we have 1 here and 1 here. So it's also 2. For 5, we have only 1. For 23, we have only 1 as well. So here we have 2 observations with the same frequency. Right? In this case, we say that we have 2 modes, 1 and 2. Again, we have 2 modes, 1 and 2. Again, the sum of the frequencies must be equal to the number of data points. So 2, 2, 4, 5, 6, 1, 2, 3, 4, 5, 6 points. A last example here, we have 5, 12, and 15. 5, 12, and 15. The frequency of each is 1, 1, and 1 for 15. If all of the observations had the same frequency, we simply say that we have no mode at all. So we can have only one mode, we can have multiple modes at the same time, or we can have no mode at all. All right? And if you think about it, mode is actually a measure of central tendency, right? Because it tells you what is the value with the highest frequency or the value that occurred the most. All right. We talked about the measures of central tendency. Now let's talk about the measures of dispersion or variability. And that includes the range, the interquartile range, or simply IQR, the variance, and the standard deviation. So let's go over each one of these. Keeping in mind that the measure of dispersion simply tells you how spread out or spaced the data points are from each other. Okay, the first one is the range. And to calculate the range, we simply get the maximum value and the minimum value, and then we subtract them from each other. So let's take an example here. We have 7, 9, 12, 23, and 4. Here, the min value, right, is 4. And the maximum value is 23. So the range is 23 minus 4, which is 90. Another example here, we have 4, 9, 12, 74, and 6. So in this case, let's put a separator here. The min would be 4 and the max would be 74. Now 74 minus 4 is 70. So the range here is 70. So as you can see, the range here gave us an idea of how spread out or the space the values are, right? In the second example, we got 70. In the first example, we got 19. So clearly, these values are more spread out, mainly caused by this outlier or high value. Okay, the second measure of dispersion includes the variance along with the standard deviation because these two are closely related. So to calculate the variance, which basically represents the average difference from the data points or the average difference of the data points from the mean, or how far the data points are from the mean on average. This is a more clear definition. Again, how far the data points are from the mean on average. That's basically the variance. All right. Now, how do we calculate the variance? We simply start subtracting the data points from the mean. Okay, so given these data points here, the mean is clearly 4, right? 6, 9, 7, 16 over 4, we have 4. Now, let's start subtracting each value from that mean by saying 7 minus 4. And then we square the value in order to get rid of the negative sign if it was present. Second, we say 2 minus 4 squared plus 4 minus 4 squared plus 3 minus 4 squared. So these are the squared differences. Now 7 minus 4 is 3 squared is 9. 2 minus 4 is negative 2 squared is 4. 4 minus 4 is 0 squared is 0. And 3 minus 4 negative 1 squared is 1. So here we have 9 plus 4, 13, plus 1, we have 14. 13 plus 1 is 14. Okay. Now, after summing up the differences or the square differences, okay, we divide that number by the number of data points in order to get the average square difference. So in this case, we say 14 by 4 by 2 is 7 by 2 is 3.5. So 3.5 is the variance. Okay. Now, the standard deviation is simply the square root of the variance. So we say the square root here of 3.5. If we calculate it on the side, we can see that it's about 1.9. So the standard deviation is equal to 1.9. All right. Now, what's special about the standard deviation is that it's expressed in the same units as the original values. So if these data points here or values represented the minute measurement of something, right? It was 7 minutes and then 2 minutes, 4 minutes, 3 minutes. Then the standard deviation is said to be 1.9 minutes. If it was meters, 7 meters, 2 meters, 3 meters, then we can say that the standard deviation is 1.9 meters. Okay, so again, it's expressed in the same units as the original values, as opposed, of course, to the variance, which is the squared differences of the values, right? Here we have another example in order to really understand the value of the variance and standard deviation. We have 4, 12, 20, and 28. For these values, the average is 16, okay? And after we calculate the square differences of these values from the mean, we see that the variance, right, is equal to 80. Whereas the standard deviation is equal, standard deviation is equal to about 8.9 approximately. Okay, so 80 for the variance, 8.9 for the standard deviation. Now, as you can see, by simply looking at these data points, we can see that these data points are far more spread out than these data points here, right? So we have 7, 2, 4, 3. They are very close to each other, whereas 4, 12, 20, and 28 are more spread out. So in this case, we expect the variance and the standard deviation to be much higher for these data points than these data points. That's why we got 80 for the variance here and 3.5 for the variance here. Right? The standard deviation, we've got 1.8 here and 8.9 here. Again, if these data points represented, for example, the meters measurement, something, right? Then the standard deviation would be 8.9 meters in this case. All right. Okay. Now let's talk about the measures of position. These include mainly the percentiles and the quartiles. So first, let's talk about the percentiles. Percentiles, right, basically divides an ordered list or a rank ordered set of elements or numbers into 100 equal parts. Okay, so 100 equal parts. So we say we have a P1, the first percentile. We have P2, the second percentile, and then P3, all the way to P100. Now, the first percentile will be equal to some value, right? The second percentile will be equal to another value, right? Now, what does each percentile represent, or what does it mean? What it means when we say, for example, the 29th percentile, assuming that it was equal to 15, okay? When we say that 15 is the 29th percentile, we mean that 29% of the data points fall below the value of 15, okay? So, assuming a school setting with some grades, right? If a certain student got a score of 80, and 80 was, for example, the 70th percentile, that means that 70% of the grades in that school were below the grade 80 or below the grade of that particular student. Okay, now, given these data points here, let's calculate some percentiles, and I'm going to use some online tool to do that simply. All right. So what is the 8th percentile? Right. In this case, the 8th percentile is 3 point. This the 8th percentile is equal to 3.3. So that means that 8% of the data points are below 3.3. Let's take another example. What is the 34th percentile, and it's equal to 5.7. So again, the 34th percentile is equal to 5.7. So 34% of the data points fall below 5.7. Okay, it's that simple. Keeping in mind that before we calculate the percentile, or before the percentile is calculated, okay, the data points must be ordered. This is crucial when it comes to calculating percentiles and quartiles. Right? Moving on, we have the quartiles and IQR. IQR basically belongs to the measures of dispersion, but we can't calculate it, okay, until we figure out the quartiles. So what are the quartiles? Quartiles divide a rank ordered data set into 4 equal parts, as opposed to percentiles, which divides the data points into 100 equal parts, right? So in this case, rather than having P1, P2 all the way to P100, we will have Q1, Q2, right? Q3 and Q4. Okay, Q1 is the same as has the same value as the 25th percentile. Q2 has the same value as the 50th percentile, which is the same as the median value. Again, Q2, the second quartile, is the same as the 50th percentile, is the same as the median value. Q3 represents the 75th percentile, and Q4 simply represents the max value, or the highest value in our data points. So, given these data points and given our online tool, let's calculate the first, second, and third quartiles. All right, there we go. So in this case, Q1 is equal to 4.5, which means in the first quarter, or 25% of the data points fall below 4.5. Q2 is equal to 9, which means that 50% of the data points are below 9 and 50% of the data points are above 9, right? Q3 is equal to 17.5, and Q4 is simply the maximum value. All right. Now, sometimes we might need the percentiles, and sometimes we might need the quartiles, but both of them essentially talk about the same story or hold the same value. All right. So we mentioned before that the range is simply the maximum value minus the minimum value, right? Now we have the interquartile range, right? The interquartile range is the value of the third quartile or the upper quartile minus the value of the first quartile or the bottom quartile. In this case, the interquartile range is 17.5 minus 4.5, which is equal to 13. So our interquartile range is equal to 13. All right. Okay. I hope you found this part informative. This is just part one. We will continue talking about other statistical concepts in the remaining parts. See you.